So today, instead of using your normal note sheet, I've decided to use your practice because it makes a whole lot more sense on the practice than the note sheets provide. So let's go through a few of the problems for 9-4. Essentially, we're doing composites of isometries. And all an isometry is a combination of a translation, a rotation, a reflection, or what they like to call a glide reflection, which just means you slide a figure right or left and then you reflect it over a line. And so these are just combinations of one or more or two or more of these different translations that we've been working with. In addition to that, isometries provide a rigid motion. The size and shape of the figure do not change. So look at what the notation looks like here. And this is essentially saying, find the image of each letter after the transformation of the reflection over reflection over line M and the reflection over line L. And really what you need to do is you need to do the second transformation first and then do the first transformation. So the second one comes first and then this first one. And the question is the resulting transformation a translation or a rotation? And then you have to describe it. So let's go ahead and take this X, and we're going to first reflect it over this line L. So oftentimes it's easier to take your paper and just fold it along this line, and then you can see the X peering out from behind here, and you can trace it, and then open up your paper and flip it back over and actually, write that on there. So if that's easier for you to do, feel free to do that. But the X reflected over the L, give or take, would look like this. You need to make sure that you have the same distance from this X to the line and from the line to this part of the X. And then we're going to take this X and reflect it over M. And it essentially looks like that. So this is the final figure right here, and they want you to compare this figure to this figure. So really, I guess you could say, you could argue it many different ways, but essentially you've translated the X down. And the distance that the X is translated is twice the distance between these two lines. Because this distance from here to here is half from here, and this distance from here to here is half. So from here to here is the full distance between the lines, and from here to here is a full distance between the lines. So the resulting isometry from the original X, the pre-image, to the image would be a translation down, I don't know where that came from, down twice the distance between the lines. So then let's look at number 2. This one's a little bit harder to do. Again, I would copy this, and then I would fold your paper along this line L, because we're going to do the reflection of L first. And then you'll see this T appearing underneath here, and then you can just trace the T, open up your paper, and trace it back again. And so if you do that, your first reflection should look something like this, give or take. Maybe made my T just a little bit longer over there. And then, so that's your first reflection, and then we're going to take this T and reflect it over line M. And so to do that, let me clean this up a smidgy. There. So the resulting isometry goes from here to here, and essentially what's happened is we've conducted a rotation. And if you look at this degree here, if you double that degree, we get a rotation that's 90 degrees, and this one happens to be clockwise. if I can spell clockwise correctly. If you wanted to look at the rotation counterclockwise, because that's typically what your book does, your book would typically say the rotation's from here to here, then you just have to find this angle here, which is twice the 45 degrees, and then you would subtract 90 degrees from 360. And so you could say, or it's 270 degrees counterclockwise. So either one of those two answers is correct. And then the point at which the T is rotating is where the two lines intersect, there at B. So it's a rotation 90 degrees clockwise or 270 degrees counterclockwise about the point V. So then let's look at these four graphs here, and you're going to perform the glide reflection image. So essentially a glide is just a slide right or left, and then you reflect over a particular line. And so here you can see the slide occurring, and this is your translation. And on this one you're going to go 3 to the right and up 0. Positive numbers on what appears to be the X in an ordered pair are right directions, and negative would be a left. And then 0 just means we don't go up or down. Up on the Y would be positive and down would be a negative. So you want to perform this first and then perform the reflection. You've got to be able to plot these lines. The y-axis, well, that one's easy. Y equals 1, we'll talk about that. X equals 2, and then we'll talk about y equals x. So let's go ahead and perform this translation first on this one. So we're going to move every point 3 to the right and up 0. And so 3 to the right means I'm going to go 1, 2, 3. So this point for D is right here, and so that's D prime. And then for M, that would be 3 to the right for M, so that's M prime. And then right here where M is now is L prime. So don't connect those dots. Then we're going to draw the line y equal the y-axis. So I'm just going to put a line where the y-axis would be. So that's right here. That's our line of reflection. So I want to find how far each of these points are from that line of reflection. So D prime is 2 units away, so we're going to go 2 units to the right, which would be here. So this becomes D double prime, because that's my second movement. And then L is 1, 2, 3 away, so I need to go 1, 2, 3 on the right. And so L is going to become here, and that's L double prime. And then M prime is right here on the line of reflection, so it doesn't actually get reflected. So that becomes your M double prime. And then you need to use a straight edge. I can't on my iPad, but you can. And then there is your isometry. Then look at number 4. So this time we're going to take every point, ignore that, take every point and move it 1 to the left and up or down nothing. So we're going to take every point here and just move it to the left first. So let's do that first. So to the left 1, this becomes D prime. To the left 1, M prime. And to the left 1, L prime. Then we need to reflect over the line y equals 1. So you want to plot a point on the y-axis at 1. So that would be here. And then I want to cut the y-axis at that point into 2 pieces, and the only way to cut it is horizontally. So this is y equals 1. And then next we're going to perform the reflection over that line y equals 1. So all of these red points get reflected over this line. So I want to look at the distance. Both L and M are 1 unit away here, so we're going to go 1 unit away on the other side. So this becomes L double prime, and this becomes M double prime. And then D is 1, 2, 3, 4 away. So we want to go 1, 2, 3, 4 away here. And that becomes D double prime. And then connect your points with a straight edge, and that is your glide reflection. Then number 5, we're going to translate nothing to the right or left, but we're just going to go up 1. So we're going to start there. Every point gets moved up 1. So this becomes D prime, this becomes M prime, and this becomes L prime. Then we need to reflect over the line x equals 2. So we want to plot 2 on the x-axis right here, and I want to cut the x-axis into 2 pieces at that point. So the only way to do that is with a vertical line. So this becomes x equals 2. And then we are going to take every one of these red points here, and we're going to find the distance that they are away from that green line. So D is 1, 2, 3, so I'm going to go 1, 2, 3 to the right. So then that gives me D double prime. And then L is 1, 2, 3, 4, so I have to go 1, 2, 3, 4 to the right. And so that gives me L double prime. And finally, M prime is just 1 away, so I want to go 1 away on the other side. So that becomes M double prime. And then connect your points, and there's your glide reflection. And the final one on this page is question 6. And so we're going to start off with translating 2 directions, right 3 and up 3. So every point gets moved to the right 3 and up 3. So this is where M prime will be. And then L would be here, L prime. And then D prime would be right here. And all I did was move each of those points to the right 3 and up 3. Then we want to reflect over the line y equals x. So let's talk about that. Y equals x is in the form of y equals mx plus b. So in y equals x, I'm missing the b, so that means that b, which is your y-intercept, must be plus 0. So it starts on the y-axis at 0, and the coefficient in front of x, which is my slope, is 1. So I have a slope of 1. So when I plot that line, I want to start on the y-axis at 0, which would be right here. And then I want to stair-step a slope of up 1 to the right 1, plot a point, up 1 to the right, plot a point, up 1 to the right, and I just keep doing that all along that graph. And then I can go down 1 and to the left 1, which gives me a positive slope still, down 1 to the left, and I can do that all the way to the other side. And then connect. I'll do my best to connect a straight line. Whoop, pretty good. So that is my y equals x, and you need to be able to plot that. Then we are going to reflect every point the same distance from here to that line. So remember, distances are perpendicular. So if you look at this square right here, this is cutting right through the middle of that square as a diagonal. So if I put a diagonal on the other side, that's the same distance. So from here to here and from here to here are the same distances. So when I reflect D prime, it's going to actually reflect here and be D double prime. When I reflect L prime, look at your diagonals. I'm going 1 diagonal, 2 diagonals. And then if I go 1 diagonal and 2 diagonals, L prime is going to be right there. So let's put L prime there. L double prime. Make my points a whole lot bigger. Okay, so then M is 1, 2, and this one's a little bit harder. Oh, that's just a smidgy. So that one's going to be much more difficult to find the distance from. So let's see. An easier way might be to look at how L is in comparison to M. So my M is going to be down here, so it needs to be below. It needs to be below my L because this is getting reflected. So think of it this way: your L1 is up 1, and to the, or your M1 is M prime is up 1 to the right 2. So if I went down 1 to the right 2, nope, that's not going to work. 1, 2, I should end up here. Oh, up 1 to the right 2. Oh, same distance. Up 1 to the right 2. Yeah, let's see if that looks right. Let's see if that's the same distance. So this is a little bit less. It's not the same. Not the same. Because they should be the same distance from each other. Should I be, because this is 2 to the right and 1 up. Because your D and your L were the same distance as well. Those worked out. So consider it this way. This right there makes an isosceles triangle. And so L is your vertex angle. Oh, I see where my mistake is. So I can't take that away. Terrific. I don't want to take that away either. Never mind. All right, so instead ignore that blue line, with that blue point. We're going to go up 2 and to the right 1. Because if we went up 1 and to the right 2, we're going to just reverse that and go up 2 to the right 1, and that should reflect it correctly. So let's see there. There's my M double prime. And now if you look at the distance, this is 1, 2, 1, 2, and a little bit. It's probably, oh, this is not going through the center like it should. So this should be 1, 2, and a half, and that's a half, 1, 2. So those are equal distances. So now if I connect the correct points, this point to this point to this point. Whew, that was much more difficult. So ignore, please, that point right there. All right, so let's look at the second page. So the second page, now you're being asked to graph line segment AB and its image line segment A prime B prime after first reflecting it across L sub 1 and then across L sub 2. And then is it a transformation or rotation? So we're going to just sketch out your XY axes. So this is X, this is X, and this is Y. And so I'm going to plot the points A and B. So if I have to add more, I will. And so the point A would be up here, and the point B would be here. And then let's go ahead and plot these lines, x equals 1 and y equals -1. So x equals 1, you plot a point, you plot 1 on the x-axis, and then to cut that x-axis, you have to have a vertical line going through there. So this is x equals 1. And then y equals -1, plot a point on the y-axis at -1, and you want to cut that axis at that point. The only way to do that is a horizontal line through that point. So y equals -1. So they first have asked us to reflect across L sub 1. So if I reflect across L sub 1, which is x equals 1, Then I'm going to figure out how far away A is from x equals 1, and so that's a distance. If you count, you have a distance of 3 here plus 1 more is 4, so I want to go 4 to the right. So I would be right here. This would be A prime. Well, actually, we're not allowed to call that A prime, so I'm just going to call that my interim A for right now. Okay, so then we're going to reflect B. Well, B is 2 units away, so we want to go 2 units away on the other side. So B is going to be right here. And then finally, we're going to reflect across L sub 2, which is purple line here. So B is the easiest one, it's the closest, it's 1 away. So we are going to reflect 1 away here. And this is our B prime. And then A is 4 away from here to here, and we want to go 4 away over here. Or it's actually 5 away. Sorry, we're 4 from here to here plus 1 more, so it's 5. So we need to go 5 in this direction. So A prime is going to be down here. So there's the first line. I'm sorry, this is the first line, and there's the second. Pardon me, I'm losing my voice. And so we end up with, I don't think they want the ordered pairs. So they say they want to know if it's a translation versus a rotation. So whenever you reflect over 2 lines, it's a rotation anyway. And so this is going to be a rotation from here to here, or you could go the other way. So that's a rotation. And they want to know the center of rotation. Well, the center of rotation is right here where the 2 intersecting lines cross. So that center of rotation is 1, -1. And so this is a rotation. All right, so then let's look at the next one, number 10. And so for number 10, whoops, I'm going to put a little line through here. So for number 10, I'm going to go ahead and go over here and just sketch. And mind you, if I had real graph paper, it would look a whole lot more accurate. Oh, we didn't do the angle rotation on this other one. Well, it'd be nice if we had graph paper. If we did, we'd do the angle rotation then. It's much harder to see on here, but the angle rotation on this one is 180 degrees, but it's hard to tell because we're not using graph paper, so it doesn't look like these are a straight line. But let's not let that bother us. All right, so we're going to sketch this one. I think I should be good here. Okay. Just pre-planning, seeing if I have enough room. All right, so I'm going to plot A. So this is A. And then B and this is B. So L sub 1 is x equals -2. So we're going to plot a point on the x-axis at -2. And we're going to cut that axis. Oops, missed it a smidgy, sorry. So as x equals -2. So we're going to cut that x-axis there at that point. And then the other line is x equals 3. So you plot a point at 3 on the x-axis, and you also cut that. So we are reflecting across 2 parallel lines, x equals 3. So we first are going to reflect over the x equals -2. So B is 1 unit away, so we have to go 1 unit on the other side. So this becomes my interim B. And then my A is 3 units away from here, so we want to go 3 units on this side. So we're going to end up right here. So my A is right here. So that would be the reflection of A over that line. Then our final reflection is going to be our A prime B prime. And so this B right here is 1. Well, my graph is not so well spaced apart, but this is 3 units apart here plus 1. So this B has an x value here at -1, so that's 1 plus 3 more makes it 4. So we want to go 4 on the other side. So there's my 4th. So 4 on the other side is going to put my B prime right there. And then for your A is 2 away, so we want to go 2 away on the other side. And so there is my A prime. And so essentially what's happened is we've had just a slide, which is a translation from here to here. So we've had a translation and if you look at the distance that A has traveled, just look at point A. A went from here to here 5 units, and then from here to here 3 more units, so that makes 8, and then from here to here 2 more units, so that's 10. So we have a translation of 10 to the right, and we didn't go up at all. So translation of 10 to the right. All right, so let's look at 12 through 15. So for 12 through 15, you're identifying the mapping as a translation, reflection, rotation, or glide reflection, and then write the rule. So let's just start with 12. So we're looking at triangle ABC. So here's ABC, and we want to see what happened to DEF. So just pick one point. So like take A, its corresponding point on DEF would be D. What happened? We went 3 to the right and 2 down. So that's a translation, each of these, 3 to the right and 2 down, and 3 to the right and 2 down. So each of those, I'm going to erase that, each of those points got translated 3 right and 2 down. So your notation would be capital T for translation, and then 3 to the right means a +3, and 2 down means a -2. All right, so the next one, DEF to GHF. So DEF to GHF. So this appears to be a reflection from here to here over a line going through here. And so you could say, well, actually it's not a reflection, because if you look, this distance from here and here, those are different. So this actually is not a reflection. So this must be a rotation. So consider this, if I took E and I rotated it, let me put it back on my pointer, E and I rotated E all the way to here, I'd have H. If I took D and rotated all the way here, I'd have G. And then F is rotating on itself, so it's actually rotating about F. F is that point of rotation. So this is actually a 180-degree turn. So turn your paper if you don't believe me. I think I might actually be able to turn my paper here. Let's see. If you turn the paper, yep, look at that. Isn't that what we started with? So a 180-degree turn of the paper. That was awesome. I'm not going to lie. So our rule for this one would be a rotation, which would be a lowercase r, my bad, sorry, a rotation of 180 degrees about the point F. And then let's look at DEF, so DEF again with IJK, IJK. So this looks like to me, look at the point F. So if you look at the point F, F has slid. Do we want to look at F? Well, F has slid to the right all the way to here, because F is where the 90-degree angle is, so F has slid to where K is. So that's 1, 2, 3, 4, 5, 6, 7, 8. So it slid to the right 8. And then it looks like it's been reflected. So for instance, if I slid this to the right 8 and then reflected it right where K is, I would end up at J. And same thing here with D. Go to the right 1, 2, 3, 4, 5, 6, 7, 8, and then it's on the line of reflection right here, so it would stay there. So this is your glide reflection. So your rule for that would be, it's a isometry. So we're going to go ahead, since we did the translation first and the reflection second. The reflection was over this line, by the way. Whoops. This is the line that it reflected on, because remember, these two were on that line of reflection, and that line is, you can see where the origin is right here. So that is y equals -1. So the line of reflection is y equals -1. And so our rule is going to be a reflection over y equals -1 with a composite. And then the first thing we did was a translation, and we went to the right 8, but we did not go up or down any, so it would be 8, 0. And then the last one that we're going to do is this one. So GHF is right here, and IJK is right here. So if you look at these, you can tell that there's a reflection, and this line right here is the line that's directly in between them, right here. And you can see that G is the same distance away as I, H is the same distance away as J, and so is F and K. And so this line right here goes through the x-axis. Here's your x-axis, goes through the x-axis right here, and here's the origin. So it's 1, 2, 3. So this is a line x equals 3. So it's purely just a reflection over the line x equals 3. And that's it.